So this video is on the last practice for Chapter 11 test. I'm actually going to give you another practice on Monday, but this one was just titled that. So on a problem like number 1, we have an addition problem with rational expressions. So we have to get a common denominator. So we have an x minus 6 here, and we have an x plus 5 here. So what we're going to need to do for this problem, okay, I am going to need to have both of these denominators. So my common denominator is going to be from the first fraction, it's going to be x minus 6, because I need that. From the second fraction, I'm going to need x plus 5. That's going to be my common denominator. So I need to multiply top and bottom of both of these fractions to get that common denominator. So from my first fraction here, I am missing my x plus 5. So I'm going to multiply top and bottom by x plus 5. So I'm going to go x plus 5 times the 7 and x plus 5 times my x minus 6, which gives me this denominator. Then for the second fraction, I'm missing the x minus 6, so I'm going to multiply top and bottom by x minus 6. So this is going to be multiplied by x minus 6 and this by x minus 6. So on top, I am going to get from my first fraction 7x plus 35. And then from my second fraction, when I do that, I am going to get a positive 3x squared minus 18x. So now I need to clean up the top. So when I do that, I am going to get a 3x squared minus 11x plus 35 over x minus 6 times x plus 5. And you always want to check to see if we can factor this and possibly simplify it. I'm just going to do this in, I'll do this in orange. I'm just seeing if this is going to factor is what I'm trying to do. So I'm looking at this right now to see if I can factor it. And if not, we'll leave it. That would be our answer. So if I took 35, here, let me do it like this. If I have a 3x and an x because of my 3x squared and a 35, I'm thinking so it'd be a 5 and a 7. If I put my 5 here, that's a 15, 15 and 7. That's not going to give me an 11. If I put my 7 here, that's a 21 and a 5. So that's going to give me a 21 and 5. That's not going to give me an 11. And if I did a 35 and a 1, that's not going to work. So my answer is going to be this. This is going to be my answer. We cannot simplify it. Let's see, number 2. So this one is a multiplication problem. So I need to factor things, okay? So from my first fraction, my x squared minus 49 here, my x squared minus 49, that's a difference of 2 squares. That's going to be an x plus 7 times an x minus 7. And then this 2x squared minus 13x minus 7, that's going to be a 2x and an x in the front. And I'm going to be having different signs, a positive and a negative, and I need things to multiply to 7. So multiplying to 7, and I'm trying to get a negative 13. I'm thinking a minus 7 because that will give me a negative 14. And then a plus 1. So that would be a negative 14 and a 1, which is a negative 13. So then I am going to do my next fraction. So for this one, I'm going to have a 2x and an x to get this 2x squared plus 9x plus 4. The 4 can be a 4 and a 1 and a 2 and a 2. If I'm kind of leaning towards the 4 and the 1 because I'm thinking if I put a 4 here, that's going to give me an 8. And then if I do this, that's going to give me a 1. So that's going to give me 9. And again, when you're doing this, you can always use the box to diamond if that's an easier method for you. So on the bottom, I can factor out a 2x, and I'm going to be left with an x plus 7. And then we want to give our restrictions. Okay, so my restriction for this one is going to be x cannot be negative 1/2. For this one, 7. For 2x, that's going to be 0. And for x plus 7, that is going to be a negative 7. So those are my restrictions. Okay, so now we're going to try to simplify. So we are going to want to see if we can cancel some things out. So I'm noticing I have an x plus 7 here and an x plus 7 here. So that and that are going to cancel out. I have an x minus 7, x minus 7. So those are going to cancel out. I have a 2x plus 1 and a 2x plus 1. So those are going to cancel. And so I am going to be left with as my answer. On top, I'm going to have this x plus 4. And on bottom, I'm going to have this 2x. So it's going to be x plus 4 over 2x. And you cannot simplify that any further. That is your answer. Okay. On number 3, on a problem like this, these are monomials. It's kind of really like laws of exponents we're dealing with here. So when I have a division problem, this I'm going to flip. Now, we give restrictions. So my restriction for both denominators, m cannot be 0 in either one, and n cannot be 0. Those are going to be my restrictions. And then I'm going to flip that second one. So I'm going to have 25 m to the 7th, n to the 2nd over 16m times. And then when I flip the second one, I'm going to get 4m to the 3rd, n to the 4th over 5m to the 5th. So number wise, I can do some simplifying. So what I notice is, let's see, 5 goes into 25 5 times. 4 goes into 16 4 times. So let me just kind of write that out real quick. So far I have 5. Now for my m's, I have m to the 10th on top because I have 7 right here, and I have 3 here, so that becomes 7. And then n to the 2nd and n to the 4th becomes n to the 6th over, and on bottom I have a 4m to the 6th because I have this m and this. So now I can clean it up even more so. I'm going to have a 5 and a 4. My m's, I have 10 m's on top, 6 m's on bottom. So I can get rid of 6 on bottom and 6 on top, which leaves me with 4 on top. And then I have my n to the 6th. And that's my answer. Okay, so this is a minus. What I would recommend doing when I have these problems is change this, and I'm gonna make it a little fainter so you can see what I'm doing. Change this to plus a negative. Okay, so it was a minus, but I'm gonna change it to plus a negative. So this is going to factor to an x plus, let's see, 6 and an x plus 2. The other denominator is going to be 3 times x plus 6. So to get a common denominator, I am going to need, from my first fraction, I'm going to need the x plus 6 and the x plus 2. From my second fraction, I'm going to need the 3. And this x plus 6 I already have, so I don't need that again. So that's my common denominator. So for this fraction, I have my x plus 6, I've got my x plus 2, I need the 3. So I'm going to multiply top and bottom by 3. So I'm going to go 3 times this, and here 3 times that. On this side over here, I have my 3, I've got my x plus 6, I'm missing the x plus 2. So I'm going to multiply top and bottom by x plus 2. So this is going to be an x plus 2, x plus 2. Okay, so now both denominators are the common denominator. And I'm going to get a 15 when I multiply the first fraction. Now, the second fraction, again, is going to be plus a negative, or I'm just going to write it like this now, minus. And then I'm going to work out x plus 1, x plus 2. So x plus 1 times x plus 2 is going to be x squared. And you can do a box if you want to, or a diamond, but basically what does 1 plus 2 add to? 3, so that's 3x. What do they multiply to? 2. So that's what I have. And then I'm going to clean this up. So I'm going to have 15 minus x squared minus 3x minus 2 over x plus 6 times x plus 2. Now I'm going to put the 3 in front. I think it looks nicer like that. Okay, and so when I clean this up, let's see, I'm going to have negative x squared minus 3x plus 13 over 3 times x plus 6 times x plus 2. Now, I can sit here and try to factor the top, but having a 13 at the end is a 13 and a 1. It's the only thing you're going to be able to get as a possible factor, and my bottom doesn't have that. So this is my answer. Okay, on number 5. Okay, so this one we're solving. So we're trying to eliminate x, x minus 8, and 3. Okay, trying to eliminate all of those. So what I'm going to do is, to get rid of each of these, I'm going to multiply by x, x minus 8, and 3. So I'm going to do it as a 3x. Okay, so 3 to get rid of that, x to get rid of the x, and then x minus 8. Okay, so I'm going to multiply that times, and let me write this a little smaller. Okay, so I'm going to do that for my 1 over x. I'm going to leave some space here. My 1 over x minus 8 and my 1 over 3. So I'm multiplying everything by 3x times x minus 8, 3x times x minus 8, 3x times x minus 8. Okay, so here the x and the x cancel out. Okay, so this x and this x cancel out. Over here, my x minus 8 and my x minus 8 cancel out. Over here, my 3 and my 3 cancel out. And now let's see what I get. Here, my 3 is going to distribute to both of those. So I get a 3x minus 8 minus 24. Over here, I'm going to get 3x times 1. So that's just going to be a 3x. On the other side, I'm going to have x that's going into both of these. So I'm going to have an x squared minus 8. And so now I'm going to get 0 here, everything else on the other side. So I'm going to have an x squared. My 3x and my 3x makes a 6x. So I'm going to subtract 6x to this side. I'm going to add 24 to both sides. So I get a plus 16 And then I forgot to give my restrictions, okay? So my restrictions is everything that makes my denominator 0. So for this one, that's going to be, can't be 0. For this one, it's going to be, can't be 8. And then the 3 is a 3. It's not going to be anything different. So I don't need a restriction for that. Okay, so just want to make sure before I get my answers and maybe have to get rid of any. So when I factor this, this is going to be x minus 8, x plus 2. So I'm going to get x equal 8 and x equal negative 2. So the problem is this one right here is the same as this. So we cannot have that happen. So this is gone. And so my answer is x equal negative 2. Similar idea on number 6. This time though, I need a factor first. This is going to be an x plus 1 times an x minus 1. That's what is called a difference of two squares. And then here I have my x minus 1 and here I have my 2. So I'm going to multiply by 2 and by x plus 1 times x minus 1. That's going to get rid of everything. So I'm going to have 2 over x plus 1 times x minus 1. And then again, this minus, I'm going to write it as plus a negative 1, okay, over x minus 1, give myself some space, equals 1 over 2. So again, I'm going to multiply every single thing by 2 times x plus 1, x minus 1. Times this by 2 times x plus 1, x minus 1. Times this by 2 times x plus 1, x minus 1. Okay, so let's see what can cancel out. So this x plus 1, x plus 1, x minus 1, x minus 1. So I'm going to be left with 2 times 2 or 4. Here, this x minus 1, this x minus 1. Over here, this 2 and this 2. Again, I forgot to write my restrictions. So my restrictions, x cannot be negative 1 or 1. This 2 is a 2. It's not going to be anything else. So I don't need a restriction on that. It's not going to become a 0. Okay. So now I'm going to get a 2 times 2, which is 4. And I'm going to get a negative 2, basically distributing into x plus 1. So it's going to be a minus 2x minus 2 equals, and then my x plus 1 times x minus 1 is x squared minus 1. And let's see, I'm going to get everything on this side, 0 on the other. So I'm going to have an x squared plus 2x. So I have a 2 over there, but I'm going to subtract it. So I'm going to get a negative 3. So now I'm going to have x plus 3, x minus 1. So I'm going to get x equal negative 3 and x equal 1. So if we are looking at these answers up here, this 1 and 1, those are the same. That was a restriction, so I can't have this one. So negative 3 is my answer. On number 7, on this one where I have numbers, basically monomials, I am going to need to multiply by something that's going to get rid of a 2, a 4, and a 3. And that's going to be a 12. And something that's going to get rid of an x squared, and an x. Well, that's going to be an x squared. So 12x squared is what I'm going to multiply by. And in terms of restrictions here, All of my restrictions are going to be x cannot be 0. So when I'm doing this, I'm going to have, I'm going to write in black. I'm going to have 5 over 2x. And then I'm going to rewrite this as plus a -3 over 4x squared. Spread that out a little bit. Equals 2 over 3x. So again, I'm going to multiply everything by 12x squared. So 12x squared times this. Okay, everything by 12x squared. And now hopefully I have some things I can simplify. So the 2 goes into 12 6 times. And this x is going to get rid of my exponent because I just have one x now. 4 goes into 12 3 times. And my x squared and x squared cancel out. On the other side, the equal, my 3, let me do it like this. My 3 goes into 12 4 times. And this x is going to cancel with one of those. So I'm going to be left with 30 minus 9 is equal to 8x. And so I get 21 is equal to 8x. So x is equal to 21 over 8. And that is not any of our restrictions. So that's your answer. So let's look at the back side. Okay, this is dealing with systems. So I'm going to call this one equation 1, equation 2, and equation 3. And looking at those, I need to decide if I want to eliminate my x's, my y's, or my z's. I can do any of them. It doesn't really matter. So if I was to try to eliminate my x's, okay, I'm looking at these x's. I have an x and an x, so I can make one of these negative, and then those would cancel. I then can multiply one of these by a -3 so that my 3x would cancel. So that's what I could do with that. If I'm dealing with my y's, and let me include my signs here. This is a positive y, this is a negative y. These are going to cancel automatically. I don't even have to times it by negative like I did in this one. And then I could times, I would say this one by a 2, sorry, just by a 2, and they're going to cancel. And then let's see over here, z, and 2z. Again, I'd have to multiply one of these by a negative, and then one of them by a -2. So I think I'm going to deal with my y's. Okay, I'm going to try to eliminate my y's. That's what I'm going to do. So eliminate y. Not because we have to, but because that's going to be the easiest. So if I take equation 1, okay, which was x plus y plus z equal 11, and I take equation 3, which was x minus y plus 2z equals 16, and I add these up, I get 2x, my y's cancel out, plus 3z is equal to 27. I'm going to call this one equation 4. So now I'm going to take the purple equation, the one that's number 2 that I haven't used yet. 3x plus 2y plus z equals 18. And I think I'm going to multiply the bottom equation by a 2. That's going to give me a negative. So I'm using my third equation, but I'm timesing it by 2. So I'm going to get 2x minus 2y plus 4z is equal to 32. And now I'm going to add these together. So I get 5x, my y's cancel out, plus 5z is equal to 50. So now I'm going to call this equation 5. So now what we're going to do is we're going to solve this system. Now, I think what I'm going to do is I'm thinking I want to divide this by, I think I'm going to do it by, not -2, sorry, a -5. So if I divide this by -5, I get -x minus c is equal to -25. And so now I'm going to use that equation with number 4. So let me just, that's not what I want. Okay, I'm going to do that right here. So I'm going to take number 4, which was 2x plus 3z is equal to 27. And I am going to multiply this equation here by 3. And that's going to make my new 5 be -3x minus 3z is equal to, and that's going to be a -75. I'm going to add these equations together. And when I do, I end up with -x is equal to negative, and when I do 27 minus 75, I get a -48, which means x is equal to 48. And so that's one answer. And now I need to find, since this system has x and z's, now I need to find my z. And if I was doing this live in person, you guys could catch my mistake I just did. I'm just noticing it. I just got, that was a big number, so I was just kind of looking at my values here. But if I am, here, let me get a yellow highlight. If I'm taking 50 divided by a -5, okay. So here, let me just move it. So if I'm doing that right there, I should not be getting a -25, because 50 divided by a -5 is going to be -10. So that should have been a -10. Okay, so right there, that should have been a -10. Highlight it. Should have been a -10, which means when I times by 3, this is now going to be a -30. Okay, -30. And so there, which means that this is going to be a -3. So x is equal to 3. So that was a mistake I made, sorry. So again, I divided by a -5 here. So I got a -x, divided this by a -5, got a -z, divided this by a -5, and I ended up with now a -10. Okay, so sorry about that. So I still need to finish solving this system. Okay, so this system right here that I'm solving, I'm not done. I found my x, I still need to find my z. So let's say I put that into the 2 times 3, so 2x plus 3z equals 27. So this is going to be a 6. So when I minus 6, I'm going to get a 21. So z is going to be 7. So now that I have my x and my z, I'm going to come back up here to either 1, 2, or 3, and I'm going to try to find my y. I'm thinking number 1. So I'm going to put it into number 1. And so when I put it into number 1, I'm putting it into x plus y plus z equal 11. So I'm going to get 3 plus y plus 7 equals 11. So basically y plus 10 equals 11. So y equals 1. So as a point, this is going to be 3 comma 1 comma 7 as my answer. Okay, let's see if I do better on the next one. Sorry. So on number 9, okay, we want to write the equation of a parabola using this format. So I am going to be putting in -2 comma 26. And when I do, I'm going to get 26 is equal to a times -2 squared plus b times -2 plus c, which is going to end up giving me 26 is equal to 4a minus 2b plus c. For my 1 comma 5, I'm going to go 5 is equal to a times 1 squared plus b times 1 plus c. So I'm going to get 5 is equal to a plus b plus c. And then I've got 3 comma 21. So I'm going to have 21 is equal to a times 3 squared plus b times 3 plus c. So 21 is equal to 9a plus 3b plus c. So on these types of problems, what I would try to do is I would try to eliminate my C's would be the easiest. To get my A's, I'd have to eliminate a 4 with a 9 at some point, and that's not going to be nice. Here I'd have to do a 2 and a 3, which is not so nice, but here these are all C's, so that's what I'm going to do. And I think I'm going to multiply the middle equation, this one here that I have in blue, by a -1. So that is going to give me a -5 is equal to -a minus b minus c. And I'm going to use that with each of the equations. So let me start with my orange one. 26 is equal to 4a minus 2b plus c. And I'm going to use that middle one, which was -5 when I multiply by -1, is equal to -a minus b minus c. And I'm going to end up getting a 21 is equal to 3a minus 3b. So I can divide by 3, and if I do, I get 7 is equal to a minus b. So let me take the pink equation. 21 is equal to 9a plus 3b plus c. And that same middle equation, -5 is equal to -a minus b minus c. And when I add them up, I get 16 is equal to 8a plus 2b. I'm going to divide by 2, and I'm going to get 8 is equal to 4a plus b. So I've got this equation and this equation that I need to solve for. So let me do that right here. And the nice thing is if I just add these together, I'm going to have my b's eliminate. So I'm going to get 15 is equal to 5a. So 3 is equal to a. And then I'm going to put that into this one here. So I am going to get, I'm just going to zoom in here. 7 is equal to 3 minus b. 4 is equal to -b. So -4 is equal to b. So that's my b. That's my 8. So I'm going to come back to my original equations, and I think I'm going to do it into my blue one. So I'm going to have 5 is equal to A, which is 3, B, which is a -4, and then plus C. So 5 is equal to -1 plus C. So C is going to be 6. And so remember, equation is going to be y equal 3x squared minus 4x plus 6. And so hopefully that helps you guys. If you need help on any of these equations, study for the test. It'll be block number 1. Okay, we'll have another review on Monday.